Dear students, welcome back to this channel. In the previous class, we have discussed the gas laws. In this video, we discussed about ideal gas. In the previous classes, we had a discussion over the Boyle's law, Charles law, Avogadro's laws. These four gases laws are known as gas laws, combinedly called as gas laws. In different gas laws, we have observed the behavior of the gases. It is a real behavior, it is a real gas behavior. In different concept or in different gas laws, we kept one thing constant and observe the behavior of the other measurable properties or measurable things. There is no gas which obeys simultaneously all laws, all gas laws. If is there any possibility, any gas which follows in at any condition follows any three laws, Charles law, like Boyle's law and Avogadro's law, then that gas is considered as an ideal gas, or the behavior is considered as an ideal behavior. It is very difficult, no? ಒಂದು ಗ್ಯಾಸ್ ಮೂರು ಲಾಸ್ ಅನ್ನು ಸೈಮಲ್ಟೇನಿಯಸ್ಲಿ ಆಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡೋದು ವೆರಿ ಡಿಫಿಕಲ್ಟ್. ಸೊ ಅದಕ್ಕೆ ಪರ್ಟಿಕ್ಯುಲರ್ ಕಂಡೀಷನ್ಸ್ ಬೇಕಾಗ್ತದೆ. ಇನ್ ಅ ಪರ್ಟಿಕ್ಯುಲರ್ ಕಂಡೀಷನ್ there may be a possibility of showing the ideal behavior. During the experiment on the gases, the scientists were observed in one particular condition, in few cases, in a few gases conditions, it behaves or it follows Charles law, Avogadro's law, Charles law, Avogadro's laws and Boyle's law. At that condition, and that gas is called as ideal gas. At that condition only, ಆ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಮಾತ್ರ ಅದು ಐಡಿಯಲ್ ಬಿಹೇವಿಯರ್ ಅನ್ನ ತೋರಿಸ್ತದೆ. In other cases it deviates. ಸೊ ಐಡಿಯಲ್ ಬಿಹೇವಿಯರ್ಗಿಂತ ಬೇರೆ ಥರ ಬಿಹೇವಿಯರ್ ಇರ್ತದೆ. ಸೊ ಅದಕ್ಕೆ ನಾನು ಹೇಳ್ತೇವೆ, ಇನ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಕಂಡೀಷನಲ್ಲಿ ಸ್ಟ್ರಿಕ್ಟ್ಲಿ ದ ಗ್ಯಾಸ್ ವಿಚ್ ಫಾಲೋಸ್ ಆರ್ obeys Charles law, Boyle's law, Avogadro's law, then that gas is known as an ideal gas. Let us discuss about the concept of ideal gas in this video. Okay? Then what's the meaning of ideal gas? First thing is, what's the meaning of ideal gas? For example, in your class or in your life, there may be a possibility of presence of one ideal person, or you are the ideal person for you. There is a possibility, correct? ಸೊ ನಿಮಗೆ ಒಬ್ಬರು ಐಡಿಯಲ್ ಪರ್ಸನ್ ಅಂತ ಇರ್ತಾರೆ. ನಾವು ಅವ್ರ ಥರ ಆಗಬೇಕು, ಅವ್ರ ಥರ ಇರ್ತೇವೆ, ನಾವು ಅವ್ರ ಥರ ಬಿಹೇವಿಯರ್ ನಮ್ಮದು ಅದೇ ಥರ ಇರಬೇಕು, ಅಥವಾ ಅವ್ರ ಥರ ವರ್ಕ್ ನಮ್ದು ಇರಬೇಕು. ಸೊ ಇನ್ ಡಿಫ್ರೆಂಟ್ ಕೇಸಸ್ ಅಲ್ವಾ. ಸೊ ಅವರು ನಮಗೆ ಐಡಿಯಲ್. ಸಿಮಿಲರ್ಲಿ in case of a gas is molecular, so one type of a gas or in one gas, that gas obeys Charles law, Boyle's law, Avogadro's law, that considered as ideal. It is hypothetical, imaginary thing. Okay, ಅದು ಇಮ್ಯಾಜಿನರಿ, ಆ ಥರ ಇರಬೇಕು, ಅದು ಆ ಥರ ಫಾಲೋ ಮಾಡಬೇಕು, ಅದು ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ಅಂತ ನಾವು ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ಕೊಂಡಿದ್ದೇವೆ. ಸೊ ಅದಕ್ಕೆ ನಾವು ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ಅಂತ ಕರೀತೇವೆ. ಈ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ನಿಮ್ಮ ಕ್ಲಾಸ್ನ ಒಳಗಡೆಗೆ ಒನ್ ಸ್ಟೂಡೆಂಟ್ complete all the workers homework and all assignments in time, and get more score in the exam and participate in all activities, sports and cultural activities like that, then there may be a possibility of considering that student as ideal ಅಲ್ವಾ. ಆ ಸ್ಟೂಡೆಂಟನ್ನು ಐಡಿಯಲ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡೋ ಪಾಸಿಬಿಲಿಟೀಸ್ ಇದೆ. ಆ ಥರ ಎಲ್ಲ ವರ್ಕನ್ನು ನೀಟಾಗಿ ಮಾಡಿದ್ದಾನೆ, ಸೊ there may be ಪಾಸಿಬಿಲಿಟಿ ಅವನನ್ನು ಐಡಿಯಲ್ ಅಂತ, ಆ ಕ್ಲಾಸಿಗೆ ಐಡಿಯಲ್ ಅಂತ ಇಟ್ಕೊಳ್ಬೋದು. ಅದೇ ಥರ ಗ್ಯಾಸ್ ಚಾರ್ಲ್ಸ್ ಲಾ, ಬಾಯ್ಲ್ಸ್ ಲಾ, ಅವಗಡ್ರೋಸ್ ಲಾಸನ್ನು ಫಾಲೋ ಮಾಡಿದರೆ ಆ ಗ್ಯಾಸನ್ನು ನಾವು ಎಂತ ಕನ್ಸಿಡರ್ ಇಟ್ಕೊಳ್ತೇವೆ, ಐಡಿಯಲ್ ಬಿಹೇವಿಯರ್. ಅದರನ್ನು ಎಷ್ಟು ಡಿವಿಯೇಟ್ ಆಗಿದ್ದಾರೆ. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಒನ್ ಸ್ಟೂಡೆಂಟ್ ಇನ್ ಟೈಮಲ್ಲಿ ಹೋಮ್ವರ್ಕ್ ಮಾಡಿದ್ದಾನೆ, ಸೊ ಅದೇ ಥರ 2-3 ಜನ ಸ್ಟೂಡೆಂಟ್ ಮಾಡಿದ್ದಾರೆ, ಎಸ್ ದೇರ್ ಇಸ್ ನೋ ಡಿವಿಯೇಷನ್, ಅವರು ಡಿವಿಯೇಟ್ ಆಗಿಲ್ಲ. ಫ್ಯೂ ಸ್ಟೂಡೆಂಟ್ಸ್ ಡೋಂಟ್ ಡೂ ಲೈಕ್ ಅವ್ರು ಮಾಡಿಲ್ಲ ಅಥವಾ ಮಾಡೋದಿಲ್ಲ, ಸೊ ಆ ಥರ ಇದ್ದವರು ನಾವು ಡಿವಿಯೇಟ್ ಆಗಿದ್ದಾರೆ, ಎಷ್ಟು ದಿನ ಲೇಟಾಗಿ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಥವಾ ಕೊಡಲಿಲ್ಲ. ಸೊ ಆ ಥರ ನಾವು ಅವರಿಂದ ಅವರಿಗೆ ಕಂಪ್ಯಾರಿಸನ್ ಮಾಡುತ್ತೇವೆ. ಸಿಮಿಲರ್ ವೇದಲ್ಲಿ ರಿಯಲ್ ಗ್ಯಾಸ್ ಬಿಹೇವಿಯರನ್ನು ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ಕಾನ್ಸೆಪ್ಟ್ ಜೊತೆಗೆ ಮ್ಯಾಚ್ ಮಾಡಿ ನೋಡ್ತೇವೆ. ಹೌ ಮಚ್ ಇಟ್ ಡಿವಿಯೇಟ್ಸ್ ಆ್ಯಂಡ್ ಆಲ್ ದಟ್. ಆ ಕಾನ್ಸೆಪ್ಟನ್ನು ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ಕಾನ್ಸೆಪ್ಟ್ನಲ್ಲಿ ಕಲಿತೇವೆ. ಓಕೆ, ಲೆಟ್ ಅಸ್ start with the meaning of ideal gas. Okay, what's the meaning of ideal gas? Any gas which strictly follows Charles law, Boyle's law, Avogadro's laws is called ideal gas. Okay, gas or any gas, any gas which follows Boyle's law, first gas laws, and the second one Charles law and Avogadro's law. Any gas which follows Boyle's law, Charles law, Avogadro's law simultaneously means at a time. Simultaneously, any gas which follows Boyle's law, Charles law, Avogadro's law simultaneously, then that gas is known as or called as ideal gas. Then that gas is called ideal gas, or in another word, the gas which strictly follows Charles law, Avogadro's law and Boyle's law, then that gas is called ideal gas. Okay, so ಅಲ್ಲಿ ಮೀನಿಂಗ್ ಏನಿರಬೇಕು, ಒಂದೇ ಸತಿ ಚಾರ್ಲ್ಸ್ ಲಾ, ಬಾಯ್ಸ್ ಲಾ ಆ್ಯಂಡ್ ಅವಗಡ್ರೋಸ್ ಲಾಸನ್ನು ಫಾಲೋ ಮಾಡೋ ಗ್ಯಾಸ್. ಓಕೆ, ಆ ಥರ ಮೀನಿಂಗ್ ಬರೋ ಥರ ಡೆಫಿನೇಷನನ್ನು ಬರೀಬೇಕು. ಓಕೆ, so then that gas is called ideal gas. Then how to represent it, the statement in terms of mathematical form. Okay, when we go to mathematical form, just it is a definition. In mathematically, first thing is it should follows Boyle's law. Okay, let us derive the equation. Okay, better to give the heading derivation of ideal gas equation. Okay, derivation of ideal gas equation. How to derive ideal gas equation, or how to give the equation mathematical form to the ideal gas? By considering the statement, or by considering the definition of ideal gas, it states that it follows Boyle's law, but it says according to. Okay, and consider the first one, according to Boyle's law. What it states? It says that at a constant temperature, volume of a given mass of a gas varies inversely with pressure. Correct? So that means volume varies inversely with the pressure. V is inversely proportional to P, or P is inversely proportional to V at constant temperature. Okay, next, according to Charles law. Okay, I've considered it as equation number 1. Next, according to Charles law, second, what it says, Charles law states that at constant pressure, volume is directly varies with the temperature. As temperature increases, volume increases. So volume directly varies with the temperature when at constant pressure. Equation number 2. Let's move on to the third one, Avogadro's law. What it states, according to Avogadro's law, V is directly proportional to amount of a substance, correct? V is directly proportional to amount of a substance at a constant temperature and the pressure. Here we call it as a constant temperature and pressure. When these terms comes to the definition, constant condition of temperature and pressure. Temperature and pressure, STP. There is a one condition, STP. What is STP? Standard temperature and pressure. At that condition, at STP condition, 0 degree Celsius or 273 Kelvin, 0.15, you can use it or not. There is no need of representation of 0.15, and pressure is more than 1 atmosphere, that means 1 bar. Okay, just higher than 1 atmosphere, 1 bar pressure. And another one condition is there, SATP. Okay, SATP, standard ambient temperature and pressure. Ambient temperature and pressure. Ambient temperature is room temperature, is considered as 298.15 Kelvin and 1 bar pressure. Please remember the values of temperature and pressure at that conditions. Okay, this part will be discussed in the next session. Okay, just for recalling the STP condition, I would like to represent here. Next, Avogadro's law. So when we consider these three laws, Boyle's law, Charles' law, Avogadro's law, we got one common factor. That one is volume. Volume become a common factor in all of these cases. When we combine equation number 1, 2, 3, what we get? When we combine 1, 2 and 3, equation number 1, 2, 3, what we get? When we combine equation number 1, 2, 3, V is common factor here in all the cases. How it varies? V is directly varies with temperature. Okay, V is directly varies with temperature and amount of substance, and inversely varies with pressure. So it is equation number 4. And just rearrange the equation number 4, or I remove the proportionality factor here, and I introduce the proportionality constant for equation number 4. After introducing the proportionality constant, V is equal to R. It is a constant, proportionality constant. Remember that I'm using R, the alphabetic R, N T divided by P, or I am just rearrange the equation, N R T divided by P. It is equation number 5. I am rearranging the equation number 5. After rearranging, it becomes V is equal to N R T. So this is the equation number 6. Equation number 6 is known as ideal gas equation. Equation number 6 is known as ideal gas equation. Here R is, what is R? R is a proportionality constant called as universal gas constant. Very important, is known as universal gas constant. Here R is a proportionality constant called universal gas constant, and PV is equal to nRT is the ideal gas equation. What's the meaning of P? Here P is pressure, V is volume, N is amount of substance, R is gas constant and T is temperature. Okay, this derivation is very important. The meaning of ideal gas is very important. So this whole concept, it may be asked for 3 or 4 marks in your exam. Therefore, it's a very important concept. uh, Exam point of view, these all the concept is very important, and there may be a possibility of asking, simply asking the equation, what is ideal gas equation, PV is equal to nRT, and as well as there may be a possibility of asking 2 marks question on these cases. What is ideal gas equation, and explain the terms P, what is P, what is V, what is N, what is R, what is T, and all that. Okay, so this is a very important concept for your exam point of view as well as for your knowledge point of view also. Next, here in case of ideal gas equation, what we observe, PV is equal to nRT, correct? So what is gas constant? Here, what is gas constant? Gas constant is R. From equation or from ideal gas equation, from ideal gas equation, if PV is equal to nRT, here R is equal to, now R equal to PV, this one go to numerator and NT, PV by NT, R is equal to PV by NT, equation number, and consider this equation number 1 now. Okay, it's a different concept. There may be a possibility of asking different type of question, derive or deduce, there is no derivation, sorry, deduce the value of R or determine the value of R using ideal gas equation. So ಏನು ಕೇಳ್ತಾರೆ ಕ್ವಶನ್, ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ಇಕ್ವೇಷನ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಆರ್ ಅನ್ನು ಕಂಡುಹಿಡಿಯಿರಿ ಆರ್ ಗ್ಯಾಸ್ ಕಾನ್ಸ್ಟಂಟಿನ ವ್ಯಾಲ್ಯೂ ಅನ್ನು ಕಂಡುಹಿಡಿಯಿರಿ ಅಂತ ಕೊಡ್ತಾರೆ. ಹೌ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಆರ್? By using ideal gas equation. In this cases, what are these constant? P is constant, R is constant, N is constant, temperature is constant, but we don't know the value of V. Value. Now questions arises. What is the value of V? How much value? In different cases, different value. At STP, what is the value of volume? Okay, let us discuss about STP. We know the concept of STP, standard temperature and pressure. What is the value of temperature? What is the value of pressure? Here temperature value is 273.15, 273.15 Kelvin, and pressure is 1 bar pressure. Bar is the unit of pressure. Atmosphere, 1 atmosphere equal to 1.013 amount of bar, slightly higher than the atmosphere. Okay, smaller than, ಸ್ವಲ್ಪ ಅಟ್ಮಾಸ್ಫಿಯರ್ಗಿಂತ ಸ್ವಲ್ಪ ಹೆಚ್ಚಿರೋ ಪ್ರೆಷರಿಗೆ ನಾವು ಬಾರ್ ಅಂತ ಎಕ್ಸ್ಪ್ರೆಷನಲ್ಲಿ ಕೊಡ್ತೇವೆ. ಇಟ್ ಈಸ್ ಎಸ್ ಐ ಯೂನಿಟ್ ಅಗೇನ್, ಆ್ಯಂಡ್ ಆಲ್ಸೋ ಎಕ್ಸ್ಪ್ರೆಸ್ಡ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಪಾಸ್ಕಲ್. 1 ಬಾರ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 10⁵ ಪಾಸ್ಕಲ್. ಓಕೆ, ಏನಂತ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡೋದು, ಪಾಸ್ಕಲ್ ಯೂನಿಟಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಬೇಕಂತ ಹೇಳಿದರೆ 10⁵ ಪಾಸ್ಕಲ್ ಆಗ್ತದೆ. ಓಕೆ, ಇಟ್ ಈಸ್ ಎಸ್ ಟಿ ಪಿ ಕಂಡೀಷನ್. At STP condition, according to Avogadro's law, Avogadro's law ಏನು ಹೇಳ್ತದೆ, or mole concept ಏನು ಹೇಳುತ್ತೆ, at STP condition any gas, ಯಾವುದೇ ಗ್ಯಾಸನ್ನು STP ಕಂಡೀಷನ್ನಲ್ಲಿ ಇಟ್ಕೊಂಡಾಗ 1 mole ಇದೆ, N is 1 mole. 1 ಓಕೆ, ನಾವು ನೋಡಿ ಇಲ್ಲೇನೇನು ಕಾನ್ಸೆಪ್ಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಯಿತು ಈ ಒಂದು ಕಂಡೀಷನ್ ಅಂತ ಹೇಳಿದ್ರೆ, ಫ್ರಮ್ ಐಡಿಯಲ್ ಗ್ಯಾಸ್ ಇಕ್ವೇಷನ್ ಅಟ್ STP ಕಂಡೀಷನ್ ಅಂತ ಇಟ್ಕೊಂಡ್ರೆ, ಕಾನ್ಸೆಪ್ಟನ್ನು STP ಕಂಡೀಷನಲ್ಲಿ ಡಿರೈವ್ ಮಾಡ್ತಾ ಇದ್ರೆ, ಸೊ ಏನಾಗ್ತದೆ, ಟೆಂಪ್ರೇಚರ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಯಿತು ಗೊತ್ತಿದೆ, ಪ್ರೆಷರ್ ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿದೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಥಿಂಗು, N ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿದೆ, ಬಟ್ ವಿ ಡೋಂಟ್ ನೋ ದ V. If we know the value of V, then very easy to calculate the value of R. Gas constant value ಅನ್ನು ಕೊಡ್ಬೋದು ಅಲ್ವಾ, ಇದೇ ವ್ಯಾಲ್ಯೂ ಇದೇ ಪರ್ಟಿಕ್ಯುಲರ್ ವ್ಯಾಲ್ಯೂ ಅಟ್ ಎಸ್ ಟಿ ಪಿ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಅಂತ ಹೇಳ್ಬೋದು. ಹೇಗೆ? ವಾಲ್ಯೂಮ್ ಗೊತ್ತಿರಬೇಕು. ಸೊ ವಾಲ್ಯೂಮ್ ಹೇಗೆ ಐಡೆಂಟಿಫೈ ಮಾಡೋದು? ಇಫ್ ವಿ ನೋ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಟಿ, ಪಿ ಆ್ಯಂಡ್ ಎನ್ using Avogadro's law, the value of identification of value of V become very easy. V is at this condition 22.7 liter. Okay, sorry, 22.4 liter per mole means 1 mole. So 22.4 mole ಅಂತ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಪರ್ ಮೋಲ್ ಅನ್ನು ಮೀಟರ್ ಕ್ಯೂಬಿಕ್ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ಓಕೆ ನೋಡಿ, ಲೀಟರನ್ನು ಮೀಟರ್ ಕ್ಯೂಬಿಕ್ ಮಾಡಿದರೆ 22.4 ಇಂಟು 10⁻³ ಮೀಟರ್ ಕ್ಯೂಬ್. 1 liter is equal to 10⁻³ meter cube. These all factors, conversion factors, that part were discussed in the some basic concept of chemistry. Therefore, at that time, it is a more, I already told that it is a more important concept. Please understand the conversion factors and collect the more units, different types of units for one properties. So it is important. Okay, how to convert liter into meter cube, how to convert bar into atmosphere into Pascal and all that. Okay, these are the very important concepts. Temperature Kelvin into degree Celsius and Fahrenheit and all that. Okay, now I am substitute the value of all this. Now I got the value. Okay, so using all this constant, I am substitute here. What is the value of R now? 10 P is 10⁵ Pascal. Okay, 10⁵ Pascal into what's the value of V? 22.4 into 10⁻³ meter cube. Okay, I'll just erase all these things because it gives the confusion for you. Next, what's the value of N? 1 mole. Next, T, temperature 273.15 Kelvin. Okay, using all these concepts or the values, the value when we calculate the things, it gives 8.314. What is the unit? Unit is Pascal. Here it is meter cube. Here mole goes to upper side and Kelvin goes to upper side. Per Kelvin per mole. If we convert the things Pascal and meter cube into bar and liter, it becomes 8.314. How to convert it into Pascal into bar? 10⁵. It comes to here in this side, it becomes 10⁻⁵. Therefore 10⁻⁵ bar and 10⁻⁻, here 10⁻³ comes to this side. Why? 1 liter is equal to 10⁻³ meter cube. It comes to here in this side means become +3 meter cube converted to liter, Pascal converted into bar. Therefore here 10⁻² 10⁻⁵ into 10⁻², sorry, +3. Okay, remaining thing is 10⁻². I think clear. If you have any doubt, please contact through WhatsApp or just calculate once again. Okay, using these two things it clears. Okay, bar, liter, these two unit converted into bar and liter, and here Kelvin remains same, per Kelvin per mole, or bar liter bar is equal to 3.15 joule per Kelvin per. So this is the SI unit of R. This is the SI unit of R, joule per Kelvin per mole. Okay, this is the value of gas constant. Sorry, here 1 4 here 8.314 joule per Kelvin per mole. This is the value of R. This is the method of deduce the value of R or calculate the value of R using this concept at STP condition. It's very important. At STP condition, the value of R is 8.314. In a previous or in olden days, STP condition is different. STP condition is, it is 0 degrees Celsius, but this one is atmosphere in olden days. Uh, Before introducing the bar, STP condition is calculated or considered, or the pressure is considered atmosphere. Atmosphere means slightly different, lower pressure compared to bar. Therefore that value of R is nearly 2.79, okay, 8.279 joule per Kelvin per mole. Okay, this one is not required now because new condition is introduced, and this, according to this condition, the value of R is 8.314 joule per Kelvin per mole. Okay, so this is about the ideal gas concept and the determination of value of R. Okay, in the next session we'll discuss about the other concept in the gas state. Okay, thank you for watching.